Our universe is dominated by mysterious and invisible forms of matter and energy that have yet to be fully or even adequately understood. Most of our universe is hidden in plain sight. Though we can't see or touch it, most astronomers say the majority of the cosmos consists of dark matter and dark energy. But what is this mysterious, invisible stuff that surrounds us? And what's dark energy and dark matter? So let's discuss about this mysterious matter and energy of universe in this video. What is dark energy? More is unknown than is known. We know how much dark energy there is because we know how it affects the universe's expansion. Other than that, it is a complete mystery. But it is an important mystery. It turns out that roughly 68% of the universe is dark energy. Dark matter makes up about 27%. The rest, everything on Earth, everything ever observed with all of our instruments, all normal matter adds up to less than 5% of the universe. In simple terms, dark energy is a hypothetical form of energy that exerts a negative, repulsive pressure, behaving like the opposite of gravity. It has been hypothesized to account for the observational properties of distant Type I supernova, which show the universe going through an accelerated period of expansion. One explanation for dark energy is that it is a property of space. Albert Einstein was the first person to realize that empty space is not nothing. Space has amazing properties, many of which are just beginning to be understood. The first property that Einstein discovered is that it is possible for more space to come into existence. Then one version of Einstein's gravity theory, that contains a cosmological constant, makes a second prediction: empty space can possess its own energy. Because this energy is a property of space itself, it would not be diluted as space expands. As more space comes into existence, more of this energy of space would appear. As a result, this form of energy would cause the universe to expand faster and faster. Unfortunately, no one understands why the cosmological constant should even be there, much less why it would have exactly the right value to cause the observed acceleration of the universe. Another explanation for how space acquires energy comes from the quantum theory of matter. In this theory, empty space is actually full of temporary virtual particles that continually form and then disappear. But when physicists try to calculate how much energy this would give empty space, the answer came out wrong, and wrong by a lot. The number came out 10 to the power 120 times too big. That's a 1 with 120 zeros after it. It's hard to get an answer that bad. So the mystery continues. So for some scientists, dark energy is that it is a new kind of dynamical energy fluid or field, something that fills all of space, but something whose effect on the expansion of the universe is the opposite of that of matter and normal energy. The thing that is needed to decide between dark energy possibilities, a property of space, a new dynamic fluid, or a new theory of gravity, is more data, better data. What is dark matter? Scientists have come up with the composition of universe that we described above. But another term, what is dark matter? Dark matter is composed of particles that do not absorb, reflect, or emit light, so they cannot be detected by observing electromagnetic radiation. Dark matter is material that cannot be seen directly. We know that dark matter exists because of the effect it has on objects that we can observe directly. It is not in the form of dark clouds of normal matter, matter made up of particles called baryons. Dark matter is also not antimatter because we do not see the unique gamma rays that are produced when antimatter annihilates with matter. Finally, we can rule out large galaxy-sized black holes on the basis of how many gravitational lenses we see. High concentrations of matter band light passing near them from objects further away, but we do not see enough lensing events to suggest that such objects to make up the required 27% dark matter contribution. However, at this point, there are still a few dark matter possibilities that are viable. Dark matter appears to be spread across the cosmos in a net-like pattern, with galaxy clusters forming at the nodes where fibers intersect. Scientists think dark matter would have been created in the Big Bang together with all other constituting elements of the universe as we see it today. Baryonic matter could still make up the dark matter if it were all tied up in small, dense chunks of heavy elements. These possibilities are known as massive compact halo objects, or MACHO. But the most common view is that dark matter is not baryonic at all, but that it is made up of other, more exotic particles like actions or WIMPs, weakly interacting massive particles. Stellar remnants such as white dwarfs and neutron stars are also thought to contain high amounts of dark matter. Since we can't see dark matter, can we actually study it? There are two approaches to learning more about this mysterious stuff. Astronomers study the distribution of dark matter in the universe by looking at the clustering of material and the motion of objects in the universe. Particle physicists, on the other hand, are on a quest to detect the fundamental particles making up dark matter. So let's see in future. Thank you guys for watching my video. Please like, comment and share this video. Also don't forget to subscribe for more space videos.